In the name of Allah, the most compassionate and the most merciful. Hello guys, I am Salar Delavar Qashqai, and in today's video we're going to model two different impact loads with single degree of freedom structure in OpenSees. You see guys, in here we have a spring and damper in here, and we are going to apply the mass as a single degree of freedom, and in here we are going to define the impact loading. So in first example we use the explosion loading with Friedlander equations. So let's see the OpenSees file. So you see, in OpenSees file we are going to define the Friedlander equations. So this code's available in my GitHub and you can change it with your own data. So this equation is going to be calculated with the defined materials such as T and as a time at each calculated pressure, and also peak pressure, and also positive phase durations, and also wave coefficients. And you see in here we defined for this single degree of freedom stiffness and mass, and also damping ratios, and defining the time step, and also impact durations of this explosion load. And you see we're going to define the explosion times series and calculating each time's pressure, and also plotting this Friedlander equations of explosion pressure loads. And also in here we're going to run the OpenSees file for this single degree of freedom system, and in here we're going to define the stiffness and also damper, and we're going to define the spring and define the material properties such as stiffness and damper properties. And in here we're going to define the explosion loading pressure, and also running the dynamic analysis. And in each step we are going to output the velocity, acceleration and base reactions, and plotting the data. So let's see if we run this code. So you see guys, after running this code, the Friedlander explosion loading is going to be plotted based on the defined pressure and time. So you see guys, we defined 2 seconds for this example, and let's see the other equations and the other result. So in here you see velocity, accelerations, displacement, and also base reactions going to be shown in here. So let's see the other example as a water wave impact loading. So you see, in second example we're going to define the pressure force of this single degree of freedom element as a PAT, and based on this pressure load of wave pressure loading, we're going to run this response analysis of these structures. So let's see the OpenSees file. So you see, in OpenSees file we are going to define the water impact time series parameters for different kinds of the wave which you want to indicate and impose to your this single degree of freedom structure. So you see guys, in here I defined many parameters. For example, in here we're going to define these coefficients as a sinus plus cosinus. So it means that, and this pressure is going to be defined to the structures as a water wave impact force. And let's see, in here we're going to plot it and also run the OpenSees file. Our process is the same, and let's see guys, in here we're going to apply this water impact loading, and then running the dynamic analysis and outputting each steps outputted data such as displacement, velocity, acceleration, and base reaction, and also plotting it. So let's run it and seeing the result. So you see guys, after running this code, you see the pressure force during the time, and also outputted data. So we are going to plot the displacement, velocity, and acceleration and base reaction of this analysis result. So that's all. Thanks guys. Please have a comment and tell me know about this kind of modeling. God bless you guys. Bye.